Earth's magnetic pole is moving quickly towards Siberia. It's clear something strange is happening. I'm your host, Diamond, and this is the first episode of Magnetic Reversal News. The news you need to know. What's causing all this weirdness? At the 2018 American Geophysical Union Fall Meeting, Livermore presented what he called a magnetic field tug of war that may offer an explanation for the recent odd behavior. The North Magnetic Pole seems to be controlled by two patches of magnetic field, he explains. One under northern Canada and one under Siberia. And here you can clearly see the dipoles he is talking about. Here and here. The one under northern Canada seems to have been stronger, keeping the magnetic pole in its clutches. But recently, that seems to have changed. The Siberian patch looks to be like it's winning the battle. It's sort of pulling the magnetic field all the way across to its side of the geographic pole. Now, if we go to the map, most compasses are now pointing. This is 2014 data where we have two dipoles and they were pointing to the center. Now this center is rapidly pulling here easterly in this direction to the north dipole over Siberia. And on Monday, the World Magnetic Model was released. We have all the documents. You can see the South Pole now is well offshore of Antarctica. And here you can see a representation of that southern pole speeding up and slowing down and speeding up. From dot to dot is 50 years. And you can see from 1910 to 1960, the baby was humming. Also 1760 to 1810, quite a distance. So it's moving in phase. It's fluxing up and down and up and down. And it's just gone through a down phase. Guess what happens now? This is going to be double. And the magnetic reversal will be complete in less than 50 years during the next phase. And here we are at the North Pole, where Al Gore lives. Watch how fast this baby speeds up. Whoa! Holy macaroni. And here we are. Now, the World Magnetic Model, we'll get to that. The World Magnetic Model is a representation of Earth's magnetic field. It is used extensively in navigation by the U.S. Department of Defense, the UK Ministry of Defense, and many civilian systems, including people with compasses. So knowing exactly where the north and southern magnetic poles are is paramount importance if you're using a map. Now, scientists first recorded the position of the northern magnetic pole in 1831. 70 years later, Amundsen found it had shifted 30 miles. And we've been watching this shift ever since, like a shift monkey. Now, Earth's magnetic field is typically believed to be like a simple dipole magnet, but that's not true. In fact, historical documents and some of the information I've uncovered shows that at many points in our history, we've had 8 poles or more. So when you're looking at sources that say that they don't know what's going on, they're full of it. And we're going to get to the facts. At the moment, the northern magnetic pole is moving away from the Canadian Arctic and into Siberia. And to keep up with the changing position, the World Magnetic Model, typically updated every 5 years, had to be updated a year early. The latest version was released at the end of 2014 and wasn't expected to last until 2020. However, the last year's users said the model had become inaccurate in the Arctic region. This was coming out from the British Geological Survey, who also made this awesome graphic. They knew before the powers that be knew, and before you and I knew. Those Brits did. And they said, yo, it's moving. And so the mainstream now is perpetrating a lie on you, because many of the top sources are claiming that they don't know what's going on. Now, my entire life's work is based on cosmic catastrophe. And the cataclysmic pole shift hypothesis was always on my back burner. But because of the excellent work by the CIA and other alphabet groups, the disinformation campaign was great. So we're going to begin by giving you the information campaign. Geomagnetic reversals are well known. A lot of people quote 780,000 years ago was the last one because of this 0.78 date. Geomagnetic reversal is a general term used to explain long periods of time, which are called crons, C-H-R-O-N, crons, where the general attitude of the pole is stable. So during the Bruness, which we're living in, the North Pole is up north in the Arctic. But during the Maruyama, for almost 1 million years, north was down in the South Pole. And during the Gauss was the same as today, the Bruness. Now look how long the Gauss is. And look how long the Bruness is. I wonder what's happening now. We could be going into a full geomagnetic reversal in the next decade. A geomagnetic reversal is a change in the planet's magnetic field. There it is. We'll get to that. Such that the positions of the magnetic north and magnetic south are interchanged. Not to be confused with geographic north and south. Those stay the same. The planet continues to rotate on the same pole. The magnetism changes. That's it. Reversal occurrences are statistically random, with some periods lasting as little as 200 years. There have been 183 known reversals over the last 83 million years. The latest, the Bruness Maruyama, occurred 780,000 years ago. Now, however, a brief complete reversal known as a Landshamp event occurred in 41,000 years ago. And that's not the only one. There are many of these events. The Mono Lake, Lake Mungo, the Landshamp, the Gothenburg. And these are geomagnetic excursions. Not true reversals, but something happens dramatic. Unlike reversals, an excursion does not permanently change the large-scale orientation of the field, but rather represents a dramatic, typically short-lived change in the field intensity, with a variation in pole orientation up to 45 degrees from the previous position. These events typically last a few thousand to tens of thousands of years, often involve declines in field strength between 0 and 20% of norm. Excursions, unlike reversals, are generally not recorded around the entire globe. But what we're experiencing is a reversal because the field strength is rapidly reducing. And a brief complete reversal, known as the Landshamp event, which they're not saying is a geomagnetic reversal because it's not on here. So geomagnetic excursions can be brief. And that reversal lasted 440 years, with the actual change in polarity only lasting 250 years. And during that change, the strength of the magnetic field weakened to 5%. That's mass extinction territory. Similar event probably happened 12,900 years ago during the Gothenburg, the largest mass extinction in the last 5 million years that we know of. So geomagnetic excursions, geomagnetic reversals, it's all terminology, kids. And those people that are not geologists, that are well studied like myself and others, well, they're just not going to have the fine-tuned data to give you. Now, the problem with these events is that through time, major ones can start erasing the data in the rock record. But it is clear over the last 50,000 years, geomagnetic excursions or reversals, which reduce the magnetic field down to 5%, have happened every 12,000 or so years, which corroborates Doug Vogt's work over at the Diehold Foundation. We'll leave you links below. How long does it take for Earth's magnetic field to reverse? We're going to get to that in a separate video. If you come look at the mainstream's position, it's all BS. They say it takes 7,000 years and blah, 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 and sometimes 400, from 1,000 to 28,000 years. Nonsense. 28,000 years for magnetic reversals to occur, yet they happen instantaneously every 12,000 years back and forth. Something is afoot. Geomagnetic excursions are well known. Geomagnetic reversals are well known. It's how we got plate tectonic theory back in the 70s. Past field reversals can be and have been recorded in the frozen ferromagnetic or ferromagnetic minerals of consolidated sedimentary deposits or even cooled volcanic flows. The past record of geomagnetic reversals was first noticed by observing the magnetic stripe anomalies on the ocean floor. Lawrence W. Morley, Frederick John Vine, and Drummond Hoyle Matthews made the connection to seafloor spreading in the Morley-Vine-Matthews hypothesis, which soon led to the development of the theory of plate tectonics. The relatively constant rate at which the seafloor spreads results in substrate stripes, from which past magnetic field polarity can be inferred from data gathered by simply throwing a magnetometer along the seafloor and reading it. And you're looking at those stripes that they recovered. Now, you can only go back 180 million years because that is the oldest seafloor that we have. No existing unsubducted seafloor exists that is more than 180 million years old. So then the data becomes spotty after that. After the, Jurassic, spotty at best. But we do know that geomagnetic reversals are episodic, periodic, and can be very rapid. Very rapid. It doesn't take 28,000 years if we've seen one on Earth every 12,000 years. Who paid these idiots for this release? We will definitely have updates specifically on the scientific nomenclature, peer-reviewed papers showing you how quickly these events can occur. And do you know what happens when these events occur? Yeah. The shit hits the fan. Earth's magnetic field is what protects us and our planet from harmful space radiation. Cosmic rays and other radiation will pour in. And that means the first effect is grid failure. Satellites and crewed space missions will need extra shielding. Our modern way of life could cease to exist, which is why this channel has been started. The World Magnetic Model updates are in. South Pole is off the coast of Antarctica, moving rapidly towards western Indonesia. And the North Pole has passed the rotational pole position, being pulled rapidly into central Siberia. There's the annual change in inclination. Based on what we see here, the South Pole is about to go through a rapid phase of movement towards the equator. And the North Pole has been speeding up your entire lives, and it's getting quicker. The magnetic field of the Earth is going to flip. Soon. How soon? We're watching it. You are going to get some of the most up-to-date information from this channel that exists in academia worldwide. The MAVSTAR Observatory is growing. The MAVSTAR Observatory is growing daily. We're about to have 9 new magnetometers on our way to 100 worldwide. where we will be able to detect the field strength of these dipoles as they move rapidly. Share this with like-minded people. Get the word out. Be safe.